Greetings from high above Grand Park overlooking scenic Westfield. It's my solution to question 8.38. Well guys, question 8.38, once again we're looking at a situation where we're taking a survey. So this time we're surveying businesses. We are contacting 150 businesses. We believe that from experience, probability of successfully getting a returned survey is 50%. So in part A, your job is to explain why we can use a binomial distribution, a binomial model to represent this. So there are 4 conditions to consider. First of all, there are 2 outcomes. The company either responds or not. So something important, you should always write in context. So please don't just list that there are 2 outcomes. Please describe what those outcomes are. They respond or they do not respond. So there are a fixed number of trials. You should specify that you know that that's the 150. There is a fixed probability for success. We are told that historically we get about a 50% response rate. And then independent trials. So whether or not one company responds is independent of whether any other company responds. They're not talking to one another and saying, hey, I just did this survey, so you shouldn't bother. So my guess is they don't have time to do such things or communicate in such ways. So in part B, the expected number of replies, n times p, 150 times a half, would be 75. So in part C, the question is asking what's the likelihood that you get 70 or fewer responses. You're told to do the normal approximation. So I'll go ahead and do that. First of all, we should check to make sure that the appropriate conditions are met for doing this. So n times p, in this case, the number of successes is 75. That's certainly greater than or equal to 10. So if there are 75 successes out of 150 trials, then there are also 75 failures. So n times 1 minus p, that's exactly the same thing. That's going to be 150 times a half once again. That's also 75, and that's greater than or equal to 10. So both of those conditions are met, and often if we're doing the actual AP exam, it would be worth actually writing it out very specifically. So 150 times a half. In this case, that is 75. That's greater than or equal to 10. Same thing, 150 times the probability of failure, which is also a half. That's 75 once again, greater than or equal to 10. We're good to go. So we already have our mean. We need to calculate the standard deviation using the formula that we know. So we have 150 trials. Both the probability of success and failure are 1/2. So the square root of 150 times 1/2 times 1/2, that's about 6.1. So now we're ready to convert this into a z-score. So we're interested in an outcome of 70. We will subtract the mean or the expected value, that's 75. We'll divide by our standard deviation of 6.1. So this z-score to the nearest hundredth, it's about negative 0.82. So we can convert this probability, which is phrased in terms of counts. We know that we can approximate this probability with the probability that z is less than or equal to the negative 0.82. So again, this is the normal approximation. This is the actual binomial probability. This is the normal approximation, which we can calculate this using the normal CDF. So we'll switch over to that here. We'll go to the calculator. So we'll hit second variables. Normal CDF is the second command. There it is. So in this case, I don't have a lower boundary, so I'm going to specify negative 10 because the z-score that I calculated is my upper boundary, the negative 0.82. I don't want to go above 70. I don't want to go above that z-score of negative 0.82. There's my mean and standard deviation I don't need to mess with. So there we go. The likelihood is about 0.206. So we'll go back and write that down. That's the likelihood using the normal approximation, 0.206. Now something to notice, you could have calculated this directly without using the normal approximation. you could use the binomial CDF command here because I'm interested in combining all of the probabilities from a count of 0 successes all the way up to and including 70 successes. So when I've got the less than or equal to symbol, it is ready to go to use the binomial CDF command. You didn't have to do that in this case, but it's good to review. So if I hit second variables, again, it takes me a while on this emulator to go down and grab the binomial CDF command. Should be getting close here. There it is. So my number of trials, there are 150 trials. The success probability, P, is 0.5. And I want to include all the values up to and including 70. So there we go. Go down and paste the command into the home screen. So notice we get a probability of 0.231. So notice these are not exactly the same. That's because this is an approximation to the binomial model. So of course, if you round to the nearest hundredth, we're at 0.21, this is 0.23. So these are reasonably close, certainly in the context of considering the likelihood of outcomes for a business survey. I'm not particularly worried about the, quote, inaccuracy in this approximation. And again, the approximation can be improved depending on certain criteria, but certainly the 0.206 is close enough to the 0.231 that it gives us the same basic idea, and that's exactly what we're going for. So back to the last part of the question then. Here's a good example of, please don't overthink the question. You're asked simply, how large of a sample do you need in order to increase the average number of responses to 100? So I just wrote in n times p. Here is the formula for the expected value. It's just I need to figure out what n is. My success probability is 0.5. I would like that expected count to be 100, so I can just solve this equation. And dividing both sides by 0.5, there we go. 100 divided by 0.5, that's 200. Although please don't work too hard because, in fact, if you think about if half of the companies are responding and you want 200, rather you want 100 responses, half respond, well, you have to find the number where 100 is half of it. That would be the number 200. So please don't overthink, if you will, sometimes these questions. That's question 8.38.